We often hear about declining health trends, but today's deep dive uncovers something really quite surprising, deeply concerning, actually. A steady, decades-long decline in fundamental male hormone levels. And, it's not just about getting older. Imagine a core part of male biology just sort of quietly shifting right under our noses. Our mission today is to unpack a landmark systematic review. It's from the Journal of Endocrinological Investigation. And this isn't just, a few papers here and there. It's a colossal analysis. It pulls data from over 1 million healthy men spanning the last 55 years. So we're going to explore exactly what this monumental study reveals about, well, the state of male hormonal health, what it means for overall well-being, fertility too, and what profound, maybe even perplexing questions it raises about broader societal and environmental influences. It's a real puzzle, and we're going to try and piece it together for you.
It really is a critical investigation, especially when you put it in the broader context of other male health trends we've been seeing, globally for the past few decades.
That's right. Yeah, to fully appreciate the weight of this new study, we kind of need to set the stage first. You might recall previous discussions we've had, or maybe just general awareness about the documented decline in sperm counts worldwide. It's been a persistent and growing concern for a while now.
Exactly. That initial systematic review on sperm counts, that came out way back in 1992. It covered data from, I think, 1930 up to 1991. And even then, it was showing a decline.
Right. Way back then.
Yeah. And then we had major updates in 2017 and 2023. These pooled insights from, well, a staggering 288 studies, and they provided really compelling evidence of a global decline in sperm counts since the 1980s, with, interestingly, a noticeable acceleration after the year 2000.
Okay. So it's speeding up.
It appears so. Now, while some have questioned these trends, their consistency across so many analyses really points to this being a real and concerning phenomenon for human fertility.
And it's not just sperm counts, is it? Clinically, we've also seen this huge, almost dramatic rise in testosterone prescriptions. I mean, just look at the U.S. data. Androgen replacement therapy, or TRT, prescriptions increased by over 350% just from 2001 to 2011.
350%, wow.
Yeah. And for Medicare patients, we're talking about a 15.5% average annual increase. So the big question that's been sort of lingering, and what this deep dive really aims to address, is whether this increasing prescription rate actually reflects a true rise in testosterone deficiency across the population, or is something else going on entirely?
That's precisely the central question this landmark study set out to answer, with those background concerns, buzzing around. This systematic review was designed as the, quote, first comprehensive analysis to systematically evaluate the historical trend of testosterone serum levels in healthy men, stretching all the way from 1970 up to July 2024. A huge time frame.
And when we say comprehensive, we really mean it. The scale of the study is just enormous. Think of like a massive data-driven detective story. They looked at data from 12,356 papers, which accounted for over 1,500 different study groups. And this included an astonishing 1,064,891 healthy men, mean age about 42.
Over 1 million men.
Yeah. To put that in perspective, that's like collecting health data on, I don't know, every single man in a city the size of Austin, Texas, just for this one study. Is huge.
And to make sure their investigation was as precise as possible, they had very specific criteria for inclusion and exclusion. They only included healthy men who had already normal hormone levels, what we call eugonatal males over 18, who had reported testosterone levels. And they intentionally excluded subjects who were selected because they had low testosterone, or those exposed to conditions known to affect hormones like certain job exposures or drug use, cancer patients, even athletes, actually, because their levels can fluctuate quite a bit.
Okay.
They also filtered out studies where the blood tests were spread out over more than 10 years just to keep a tight focus on those, temporal trends.
And it wasn't just testosterone they looked at, right? They gathered more data.
That's right. These researchers meticulously extracted data for other key hormones, too. So luteinizing hormone, LH, follicle-stimulating hormone, FSH, also sex hormone-binding globulin, SHBG, and importantly, body mass index, BMI. This broader data set was really crucial for trying to understand the full picture.
Makes sense.
And their analysis was incredibly rigorous. They used a sophisticated method called meta-regression analysis, and they adjusted for several potential confounding factors, things like the subject's age, their BMI, and crucially, even the specific lab method used for measuring testosterone over the decades, which, as you can imagine, is vital if you want to compare historical data accurately.
Yeah, lab tests change over time.
Exactly. And they even went a step further, exploring potential environmental and societal factors too, really trying to leave no stone unturned.
Okay, so this monumental effort, this massive scientific detective story,
Yeah.
what did they finally uncover? What's happening to male hormones over the last 55 years? What was the big reveal?
Well, the core finding is pretty stark and clear. A significant reduction in mean serum testosterone levels across the years of measurement. And this wasn't just like a slight dip, it was a statistically undeniable decline. Suggests a pretty profound shift is underway.
Okay, so my first thought, probably like many listeners, when hearing that is, okay, but is this just, a natural part of aging? Or maybe it's related to the rising obesity rates we hear so much about.
Mhm.
Did the study manage to untangle those sort of obvious factors?
That's the crucial question, isn't it?
Yeah.
And the answer they found is powerful. This decline was observed independent of BMI and age.
Independent. Okay.
Yeah. Even when they specifically looked only at study groups where the men had a healthy BMI, less than 25, the decline was still significant. And what's really compelling, I think, is that this decline was seen across all 6 age groups they studied.
All of them.
All of them. From men aged 18 to 30, right up to those over 70 years old. It truly seems to be a systemic trend affecting men regardless of their age or weight, at least within this healthy group they studied.
Wow. So it's not just an aging thing, not just a weight thing. It's hitting younger men, too, across the board. Did the pace of this decline stay the same over the decades? Or did that change?
No, it didn't stay the same. The decline was definitely present both before the year 2000 and after, but it actually accelerated post-2000.
Accelerated.
Yeah, it essentially doubled its pace after 2000, which suggests the trend isn't just ongoing, but maybe even intensifying.
Mhm.
And intriguingly, this significant negative trend held up even when they looked only at papers published in the USA. So it indicates a widespread geographical consistency, probably not just some localized issue.
Okay. And what about the different lab methods? You mentioned they accounted for that. Did the changes in technology over the decades affect the findings at all?
That's an excellent point because measurement methods have absolutely evolved. So the decline was confirmed for studies using the common sort of older methods like immunoassay, IA, ELISA, and radioimmunoassay, RIA.
Right.
However, it was not confirmed for mass spectrometry, which is a newer, often considered more accurate method.
Ah, okay. So maybe the newer methods don't show it.
Well, here's the important caveat. Only just five out of the 117 mass spectrometry papers were actually conducted before the year 2000. So there's very limited historical data using that specific method. It makes it really difficult to draw definitive conclusions for mass spectrometry across such a long time frame. We really need more data points there, especially older ones.
Got it. So the jury's still out a bit on the very latest measurement tech over the full period. And it wasn't just testosterone going down, was it? You mentioned LH, luteinizing hormone. That was also on a downward slope.
You're absolutely right. LH serum levels also showed a significant decline over the years, and that was after adjusting for the subject's age. This particular decline, the LH one, was confirmed in 3 out of the 6 age groups they looked at. The 1830 group, the 3140 group, and the over 70s.
Okay. So testosterone and LH both going down. What about the other things they tracked, like FSH, SHBG, and crucially, BMI within this specific study population? Did those change?
This is where the plot thickens even more, actually. FSH and SHBG did not show any significant temporal trend in this study. They stayed relatively stable.
Okay.
And critically, despite the, well-known global obesity trends we're all familiar with, the BMI in this very specific population of healthy men that they studied also did not show any significant change across the years of observation.
Really? BMI didn't change in this group?
Not significantly, no, which is incredibly important because it really strengthens the finding that the hormonal decline isn't simply a secondary effect of rising obesity, at least not in this specific healthy cohort they focused on.
Wow.
It points to something else entirely, something maybe deeper going on.
So what does this all mean when you put it together? The simultaneous decline of both testosterone and LH, independent of age and BMI. This points to a really significant conclusion about where the problem might actually be starting, doesn't it?
That's exactly right. The fact that both testosterone made in the testes and LH, the signal from the pituitary telling the testes to make testosterone, are both declining. It strongly suggests the problem does not primarily originate in the testes itself, the primary factory, so to speak.
Okay. Not the factory's fault, then.
Probably not primarily, no. Instead, it points towards a central resetting of what's called the hypothalamic pituitary testicular axis. That's the intricate communication pathway between your brain, specifically the hypothalamus and pituitary, and your testes. It's like the command center itself is recalibrating its settings downwards.
Okay, central resetting. Can we get a little more specific? Does the study give clues about whether it's the hypothalamus or the pituitary gland that seems to be driving this change? Can it tease that apart?
It does offer a fascinating clue, actually, and it comes from looking at LH versus FSH. Remember, LH levels are declining, but FSH levels are not. So think of it like this. Your brain sends a master signal, called GnRH, down to your pituitary gland. And that signal has both a rhythm, how often it pulses, and a strength or amplitude. LH secretion seems more dependent on the rhythm, the pulse frequency, while FSH is more dependent on the strength, the amplitude.
Yeah.
So the fact that we see LH declining but not FSH suggests subtle changes in that GnRH pulsatility, the rhythm originating at the hypothalamic level. That's the brain's ultimate signaling center in this chain. It points more towards the hypothalamus than the pituitary gland itself being the primary site of this resetting. It's a more nuanced origin than just, say, the pituitary failing.
That's really fascinating. A change in the brain's signaling rhythm. And that naturally makes us ask about the big external factors we always hear about with health trends. What role did environmental factors play? Or population changes? Did the study's analysis shed light on those?
They did look into this rigorously. And this is another truly surprising insight from the study. They found that adjusting their models for various common environmental factors, things like energy production levels, consumption, trade data, emissions, even measures of air pollution adjusting for these, did not significantly change the observed decline in testosterone and LH levels.
It didn't. So those factors didn't explain it.
Not according to this analysis, no. It indicates that these factors, as they were measured in this specific study, don't seem to explain the trend. And similarly, when they adjusted for population growth-related parameters like life expectancy changes, mortality rates, birth rates, population numbers, that also did not significantly explain the decline in LH, and the impact on testosterone decline was very limited.
Huh. So it's maybe not the usual environmental or demographic suspects we might immediately jump to, at least based on this huge data set. What about things like lifestyle, stress? We know those can definitely affect hormones.
Absolutely. And while factors like lifestyle habits, diet, exercise, sleep, stress levels are indeed known causes of what we call functional hypogonadism, meaning low T due to external factors, they are incredibly difficult to collect consistently and accurately on a global scale across thousands of studies spanning decades.
Yeah, that makes sense. Hard to measure reliably.
Exactly. So that limitation makes it really challenging to assess their specific role in this large-scale trend identified by the review. But what this new finding about declining testosterone and LH, independent of age and BMI in healthy men, what it truly does is add another significant and frankly alarming layer to that existing picture we talked about earlier regarding male fertility decline and overall male health concerns.
This is such a powerful study then, offering some really profound insights. But of course, no research is perfect. No study is without its limitations. What should our listeners keep in mind as they sort of digest these findings? What are the caveats?
Yeah, it's always important to maintain a balanced view. Firstly, the data was extracted from existing published literature, which means that potential selection biases or participation biases in the original studies can't be entirely ruled out, even though the researchers applied really rigorous search methods and quality checks.
Yep.
Also, data for all the environmental and population-related factors weren't available for every single included study. They just didn't report it back then, or it wasn't collected. And that could limit the statistical power of those specific correlation analyses looking at environmental links.
Right. Missing data is always an issue.
And finally, the method itself, meta-regression, relies on aggregate data study-level averages rather than individual patient data. And that approach has its own inherent limitations compared to analyzing raw individual data points.
Understood. Good points to keep in mind. Well, this deep dive has presented some truly thought-provoking information about male hormonal health. It paints a picture that's both, well, clear in its findings, but also complex in its implications. And as always, we'd like to leave you, our listener, with something to ponder, something that builds on the source material but maybe invites a bit more contemplation. The paper itself, despite its rigorous findings, does touch on a more speculative idea about the ultimate why behind this decline.
Indeed, it does. Towards the end, the authors briefly suggest, very speculatively, that perhaps this decline could be seen as some kind of long-term adaptation to overpopulation,
Hmm.
or maybe a move towards a new population homeostasis, a sort of natural rebalancing.
Hmm.
Now, they are very clear to acknowledge that the current data doesn't fully support this as a direct cause of the decline. It's not like they proved it, but they raise it as a conceptual possibility, perhaps a long-term evolutionary or societal shift perspective to consider.
Okay, so that leaves us with this kind of lingering question for you, the listener. What do you think about this speculative idea? An adaptation to overpopulation, does that resonate at all? Or, given all the compelling evidence we've presented today, the decline being independent of age, independent of BMI in healthy men, and seemingly not fully explained by those measured environmental factors. What other factors might you consider to be at play in this ongoing significant decline in male testosterone and LH levels? It really is a biological mystery that continues to unfold. And it feels like we're just at the beginning of truly understanding its full implications for, well, for humanity.